by choice, my groups generated by this line and its opposite is normalized by T because T acts by homothety, and so you get FA for each A, namely the two lines generate a group which is normalized by T, you put in T there. And then the group generated by all these as you vary things over delta is a nice split group from this construction. And that's a Levy subgroup because when you go modulo the radical over K bar, of course, you only see SL2s or PGL2s, which we have recovered already. So this is the construction of Levy. Of course, much easier said than done, but the proof is essentially this. Okay, so having got a Levy, now we want to describe, and that will be my next talk, but let's begin. My next talk will be to describe all pseudo-reductive groups up to some certain central extensions, at least when they are pseudo-split. So for example, if you are happy to work with separably closed fields, then you have a very quick description. Now there is one catch here, and this catch is that over even separably closed field, you can have root system which is non-reduced. And those guys are very difficult to construct. So let me explain to you how this non-reducedness comes about. So you see, let's take the group G to be pseudo-reductive, and you have the geometric unipotent radical. And this, as Brian said last time, that there is a minimal field extension K of small k, which is purely inseparable, finite extension, over which things become defined. It has to be purely inseparable because over separable extension, you don't see any change. So this is a purely inseparable extension, and so what you do is you look at GK, you go up to this finite extension, and then you look at GK modulo the K unipotent radical, which is over K bar, this full geometric radical. Okay, so you go to this group, and we have always tried to denote this group by G prime. So G prime is a reductive group, but not defined over the base field, but over a canonically given purely inseparable extension. And this group G prime is our reductive quotient. So coming back to the topological situation I described, so the group of rational point I said is isomorphic to group of rational point of a reductive group. So this is the reductive group, and the group of rational point over small k is the group of capital K rational point of this group only when you are in local and global situation, not otherwise. Otherwise it's false. Okay, so now you see what happens is that if I start with a maximal torus here, okay, so if you start. Oh, okay, so I will continue next time. It's a good place to stop. So what I'm going to describe next time is all such groups or separably closed fields.
Maybe you can answer your questions during time.
Okay, we will have questions in the next time, Good. So you have chemistry exam here?
Physics.
Physics. Okay, good. Good luck. Yeah. Maybe you can discuss some of these things in the exam.
Let's see. If I could at least figure out what you taught.
Yeah, this is very high level math.
This is mathematics?
Yeah. So you want to collect all this? Maybe some, okay.
I think we should have. I think I have enough.
Yeah. And your camera,
Yes, I'm going to collect it now. Yes.